Okay, 9.3 is about angles of elevation and depression, and our objective is to use angles of elevation and depression to solve problems. So first we need to know what those are. An angle of elevation is an upwards angle from a horizontal line. So in a lot of these problems, that horizontal line is our line of sight, and then there's an angle up to something in the sky. Okay, an angle of depression is a downward angle from a horizontal line. So that'd be like if we were looking down at the ground at something. So if we look at this picture, B from this horizontal line is an angle of depression because it goes down. A, if this is our horizontal line, points upward, so this is an angle of elevation. Okay, so if we look at example 1, one side of the angle of depression is a horizontal line. Angle 1 is an angle of depression because it goes down from this horizontal line, it points down. Angle of depression from the plane, so it goes from here to the tower. One side of an angle of elevation is a horizontal line. So if we look at angle 2, here's our horizontal line. Angle 2 is an angle of elevation because it points upward from the tower to the plane. Okay, so angles of elevation and depression. Okay, let's take a look at the second example, surveying. A surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. The angle of elevation to the top of the building is 35 degrees. How tall is the building? Okay, so this angle is 35 degrees. We know the tangent is opposite over adjacent. And those are the two sides we're working with. So the tangent of 35 equals x over 200. We're using the tangent ratio. And we're going to multiply 200 times the tangent of 35 to get our answer. So type 200 tangent button 35 into your calculator, and you get 140.041508, which is about 140 feet. So to find the height of the building, add the height of the theodolite, so the 5 feet. So we're going to add 140 feet plus the 5 feet, and then 140 plus 5 is 145 feet tall. So total from the ground where this is sitting to the top of the building is 145 feet tall. Example 3, aviation. An airplane flying 3,500 feet above the ground begins a 2-degree descent to land at the airport. How many miles from the airport is the airplane when it starts its descent? So we're going to look at this triangle here. We've got 2 degrees, this is opposite, and this would be hypotenuse because it's the longest and the slanted side. So if we think about our abbreviation, SOHCAHTOA, we have opposite and hypotenuse, so we need the sine. So we're going to use the sine ratio, and the sine of 2 equals 3,500 over x. So we're going to do 3,500 divided by the sine of 2. So type in your calculator 3,500, divide sine hit the sign button, put a 2, and then close the parenthesis. We're just dividing by the sign of 2 is all this is saying. And we get about 18.99, which if we round is about 19 miles from the airport when the plane starts its descent. Okay, there are some check for understanding problems, and we are going to go through them together. Feel free to pause and answer the questions and then check them with me after you're done. So describe angle 3 in example 1. So if we go back to example 1, we're looking at angle 3. Well, from this horizontal line, it goes down, so it's an angle of depression, and that goes from the tower to the person. So we're going to say angle of depression from tower to person. Okay, we need to look at angle 4. So angle 4 goes from this horizontal line upwards from the person to the tower. So this, since it goes upwards, would be an angle of elevation from the person to the tower. Okay, number 2, you see a rock climber on a cliff at a 32-degree angle of elevation. The horizontal ground distance to the cliff is 1,000 feet. Find the line of sight distance to the rock climber. So we're just trying to find from your eyes to the rock climber. So we know this is 32. We have the adjacent side, and we're trying to find the hypotenuse. So Gatoa, we have adjacent and hypotenuse, so we need the cosine. So the cosine of 32 equals adjacent, which is 1,000, over hypotenuse, which we don't know. So we need to do 1,000 divided by the cosine of 32. So whenever x is on the bottom, trade them. 1,000 divided by the cosine of 32 is 1,179.78. Whoops. So x, or the distance to the climber, is about 1,179 feet. All right, last problem. An airplane pilot sees a life raft at a 26-degree angle of depression. So we're going to put the airplane flying straight here. And I won't draw the airplane because you don't want that. Okay, then at a 26-degree angle of depression, he sees a life raft. The airplane's altitude, so straight up from the life raft, the airplane is 3 kilometers above the life raft. What is the distance from what is the surface distance from the raft? So just the distance between the plane and the raft. We don't want to know the actual distance. It's like if they're both on the ground, how far away would they be? So we have the opposite and the adjacent, so we need the tangent. This is opposite, this is adjacent. The tangent of 26 equals opposite 3 over the distance d. So then we're going to trade. So the distance equals 3 divided by the tangent of 26. So in your calculator, 3, divide sign, tangent button, 26, and hit the parenthesis. So the distance is about 6.15 kilometers, or we can round it to 6 kilometers from the airplane to the life raft. Okay, those are all the examples we have. Go ahead and get started on your homework. If you have any questions, just let me know. I'll be happy to help you.